Okay, welcome back. Let's dive into the good stuff. This is why you're here. I told you when we started, this video was really meant, and this exercise is really meant for someone that's brand new to machine learning, never touched it before, never used it before. And we already have a good understanding kind of what we're doing, why we're here. We have an understanding of the business problem that we're trying to pull apart. We even have an understanding of the data that we're going to be using. Even though we might not have domain knowledge or really an expertise in that area just yet, that's okay. We're going to use some statistical tools and some machine learning algorithms and things of that nature down the road to help us further understand some of that stuff. But before we get too deep, let's dive into the concept of machine learning. So there are a lot of different types of machine learning, and a lot of them answer many different questions. We're going to start out with the most basic type, and I use that term very loosely because I don't want you to think that this is easy. I tell my students all the time, always remember to keep telling yourself what you're doing is hard. It is really difficult. The way that it's being presented and by mapping it to a business problem first, I really think is a good way for you to learn what machine learning is. So let's get into the most quote unquote basic machine learning that there is, and it's called supervised learning. Now, the reason it's called supervised learning is because you are going to be working with data that has already been gathered. I already told you in the second exercise, right? We went through that data together, sort of what it actually looked like. We had 7 different variables. We mapped 1 through 6 as inputs, and we said we were going to actually predict, or we're being asked to predict the amount of solar radiation. So that data set is historic. It's already happened. And because we have that data to use for this particular problem, what we're going to use is we're going to use a tool called an algorithm, and we are going to apply that algorithm to that historical data. And the machine learning part comes in, right? When that algorithm learns to map a certain combination of these inputs that have already happened to this output. Remember, this is every single row in this data set happens this way. So all that sounds really complicated, and I've got this really cool picture of an old bike on the screen. So let me tell you how I actually think about supervised machine learning. So what I like to do is go all the way back to my childhood memory. All of you listening to this at some point in time learned to do something for the first time. One of my fondest memories when I was growing up was actually of my father teaching me to ride a bike. And, you know, I have got 3 older brothers. So my dad teaching me to ride a bike versus my 3 older brothers was probably a savior in itself. But my dad really didn't show me how to ride a bike. He really just sort of stuck me on it and let me fail slightly each time until I really figured out kind of what to do. But this didn't mean I didn't watch other people ride bikes, or I watched my brothers ride bikes, or I watched my dad ride bikes, and I learned from what they were doing, and I learned from what I was doing. And some of the things I quickly figured out I didn't even need to even try to do anymore, right? So in my mind, learning to ride a bike quickly boiled down to just a certain number of things that I had to get right. And that's what we're doing in machine learning. We're taking those inputs that we've previously have identified, and we're mapping those to a certain outcome. And in the case of riding a bike, it's whether you ride the bike or whether you fall off the bike. And if we look at that, we really break any machine learning, any supervised machine learning problem that's similar into 2 parts. And one of those is a record or an observation. This is the rows in a data set and the results of each trial. So I've got an example here on the screen that I'll show you. If we break down the concept of learning to ride a bike, and we tried and we tried and we tried when we were small, and a lot of things we figured out we just didn't need to do anymore. There was really about 5 or 6 things that were really important to us. We figured this out over time. Maybe we had somebody tell us this up front. Maybe we had somebody show us this up front. But subconsciously, we had to get this specific combination of things right before we actually successfully rode a bike. So I've got the features here, the things that are really important for riding a bike. I've got those highlighted in yellow in separate columns. Were your feet on the pedals as you started to ride a bike? Did you get a good running start to get your momentum? When you got your momentum up and you jumped up on the seat, did you have good balance? Were your eyes shut? Were you scared to death, right? These are humorous things, but they all go into us learning to ride a bike. And every time you successfully recorded, maybe subconsciously, whether you rode the bike or whether you fell off. This is exactly what a machine learning algorithm is learning from. This concept of a combination of features and a successful or not successful outcome in this case. So if we boil this down to something really at a 50,000 foot view, a machine learning algorithm is looking for the perfect combination of features and the outcome that is related to those perfect combination of features. I need to stress that you need to understand that this happens for every single row in this data set. Remember, this is a supervised learning problem, and we have the benefit of having this data to provide to the algorithm so it can learn these things. So what is being learned? Again, the algorithm is trying to learn the relationships that this combination of features have to a specific outcome. In this case, whether you rode the bike or you didn't ride the bike. In more math-related terms, you've got inputs to a problem and you've got an output to a problem. We've already specified those for our solar radiance problem. The inputs are mapped into a function that relates to an output. That's exactly what is happening in mathematical terms in supervised machine learning. So what is actually being learned in that process? We summarized it in pictures, right? But what is actually being learned in that process? Well, in this case, if we go back up to our business problem, what our algorithm is trying to figure out is at a certain time of day, given a certain air temperature, humidity, dew point, barometric pressure, and wind speed, what is or what was that solar radiation? Remember, these things have already happened. We've already recorded thousands and thousands of these events. Well, if a machine learning algorithm can then figure out what these specific relationships are to the individual outcomes, it produces a set of rules for us. And guess what? We can take that set of rules and apply it to a new set of data with a similar structure, with the same variables in it, but with an unknown amount of solar radiation, and we should be able to quote unquote predict the amount of solar radiation, because all we're doing is having a machine learning algorithm replicate what's happened in the past. Now, there's a certain amount of error that happens in that. You know, don't believe all the hype that you hear in the movies, right? Or Terminator, or whatever you think. Machine learning is not perfect, and the bulk of our job as ML engineers or AI engineers or data scientists, data analysts, whoever's going to be using machine learning, the bulk of our work is actually learning to assess the algorithms, learning to know which particular algorithms to use on what type of data, and more so than anything, learning what we should do to the data to make it applicable to machine learning. There's a lot of data cleaning, there's a lot of data modifications that happen before you even get into sort of the good stuff with building machine learning models. So that's machine learning. That's the objective I want to cover in this supervised machine learning anyway. The objective I want to cover in this particular video. Let's dive into actually doing this. So I'm going to be covering that extensively in the next video, where we're going to have a learn by doing exercise and start to wrap up the remainder of this content. See you in a minute.